Hello everyone, this is Kasinul Sai Padmakar presenting on behalf of our team 114. Our paper ID is 114. So my teammates are Samin and Satvik Chowdhury, Paulu Kumar Jashwant and Gandhiraj Arvind, and our corresponding author is Dr. Divya Odenje. We are from Amrita Vishwavidya Peetam. So our project title, our paper title is Fire Detection through Surveillance Videos using Deep Learning in Real-World Applications. So this is a final year project, and based on the project we have done, we have wrote the research paper and got accepted to the ICMISC 2022 conference. So let's start our presentation. So firstly, a problem statement is to build an efficient recurring convolution neural network based system to detect fire in videos that are captured in surveillance scenarios. So basically, a vision-based fire detection framework has lately picked up popularity when contrasted with customary fire recognition framework dependent on sensors. So here the need of video perception in private, modern or business regions has expanded the use of vision-based fire acknowledgement system. So recently there are lots of fire accidents has occurred due to the improper surveillance or unable to cover those uncertain regions like restricted areas in forest or any factory buildings. So what happens with sensors is they'll be having a particular range. If there's any presence of undetected fire out of their range, they cannot detect that presence of fire. So that's a drawback of sensor. So to overcome such accidents, we propose a new method using convolution neural networks. So coming to the problem description, to detect fire, researchers they have presented both traditional and learned representation-based fire detection methods. In literature, the traditional methods use either color or motion characteristics for fire detection. For instance, they use color features for fire detection by exploring different color models, including HSI, YUV, YCBCR, RGB, and YUC. So these are different color models. The major issue with these methods is their high rate of false alarms. Several attempts have been made to solve this issue by combining the color information with motion and analysis of fire shape and other characteristics. So our proposed method, we propose an efficient RCNN based system, as said before, for fire detection videos captured in uncertain surveillance areas. So here our approach uses lightweight deep neural networks with node dense fully connected layers, making it computationally inexpensive. Once detected a fire, the information will pass through the Firebase. Firebase, it's nothing but one type of database. Then the Firebase will send a notification to the smartphone. So this is our overall working procedure. Firstly, we'll take the video input from the webcam. So right from the video stream, the video directly goes to the convolution neural network. There, the classification occurs, whether if there's any fire or not. If there's any activity recognition, then it goes straight to the database, and from there, a notification will be sent to the smartphone. So this entire project we divide into two phases, phase one and phase two. So phase one is nothing but the basic things we need to complete to get start over. Those are dataset collection, pre-processing, building of the CNN network, building the model, training of the model, and evolution of the model. So data collection. So we initially for any experiment to begin, data collection is a key step uh, to start over with. So here in our process of fire detection also data collection, it played a pivotal role. So this data set we downloaded from Kaggle. It was created during the NASA Space Apps Challenge in 2018. So here the goal was using this data set, we need to develop a model that can recognize the images with fire. And data pre-processing. So before going over with the images that are collected with the data set, we need to pre-process them to make a model effective. So the images they need to be pre-processed before making them as a training set. So they need to be resized and converted to grayscale images. So here all the images will be resized 128 into 128, because when we train with huge vertical or horizontal images, it is vital to resize them in convolution neural networks, as there are as they are memory intensive, especially for training. So reducing the input image resolution helps the model to function better. And also normally it requires just 8 bits to be represented. And also we need to convert the image to grayscale images, because the color image it takes 3 times as long as processing a grayscale image. And also it's very less expensive to operate on a single channel image. That's why after resizing we convert each image to grayscale image. And yeah, coming to the model, it's a 2D convolution layer. This layer, it creates a convolution kernel. Um, it, it is mined with layers. From the input, it helps produce a tensor of outputs in a linear manner. So here our architecture is a sequential model in nature where a linear stack of total of 5 layers from the first layer. So we do the kernel size 5 into 5 matrix with input 128 and 128 matrix, like we do dot product to produce the fusion matrix, which includes the filter size, and also it determines the dimensions of the kernel size 5 into 5. And normally we use padding and ReLU function in this. And also here we use a dropout value of zero point 0.2, and finally we sum with the flattened layer for the resultant fusion matrix. So the flow in the CNN forward will be like input layer, convolution layer, ReLU, and then max pooling, and then again convolution layer, ReLU, pooling, and flatten, and finally the softmax function. So after all this, the immediate key step is to train the model. So the model will be trained with the pre-processed data set, and during the training, feature extraction and pattern recognition will happen with the help of CNN architecture. So after the training, it can detect any presence of fire. So after training, the next immediate key step is to evaluate our model of how it performs. So we divide the data set into training set and testing set. It was divided in the ratio 1:10. And initially we just performed 5 epochs to see how the model responds to the data set. So after 5 epochs, the accuracy got settled at 83.33, but finally after complete training, the accuracy got at 98.4, and the model can generalize the data set, and it can differentiate any random image whether it consists of fire or not. So that's up to phase 1. In phase 2, what are the parts we completed are fire detection of input videos. Initially, the model was trained on image dataset, so it detects fire from the images. So from that, what we did is we extended our work such that the build model can recognize the fire from input videos. So it's nothing but taking frames from the videos. So it takes frames for every second from the videos, and from that frames it identifies the presence of fire. And then moving forward, we implemented real-time fire detection. So real-time fire detection is similar to fire detection from input videos. It's nothing but uh, the video input will be given by the webcam. So simultaneously the video will be running and the detection of fire also should take place. And the final step is to implement notification to the user. So for this, a database needs to be created and the user will be notified if there's any presence of fire. And yeah, he can see the all the records of fire incidents that have been occurred. So I'd like to show some sample video of fire detection from the input video. Um, So this is the input video. This is a test video we have given from our PC. So if there's any detection of fire in that video at that frame, the border becomes red and there will be a label written on the screen called fire. So yeah, if there isn't any fire in the video, then the border becomes green and there will be a label written called clear over the screen. So like this, the model detects the presence of fire from the input video, and immediately if there's any fire detected, the borders get changed to red and the label will be changed to fire. So two outputs fire or clear will be displayed along with the colors of the border, red or green. So I would also like to show about real-time fire detection that we implemented. So here, this input was taken from the webcam. So if there's any fire detected, same as shown in the previous slide, the borders becomes red and there will be a label called fire written. And if there isn't any fire, then what happens is the borders become green and there will be a label called clear over the screen. So that's all about our project and the content we'd like to present that is written on our research paper on the of the submission ID 114. So thank you all for giving this opportunity, and especially thanks to my team and our corresponding author, our guide Divya Oden ma'am, for helping us and clearing us if we got any doubts and making our way forward. Thank you everyone.